Hello, I'm Simon Dodd. I'm with STMicroelectronics, and we are at Embedded World, and we're demonstrating some biosensors from STMicroelectronics today.
So, biosensors, what is the latest with your biosensors?
What is the latest? Our biosensors, one of the coolest things we've done with biosensors is with our ECG patch here. So in our ECG patch, this is a full reference design for remote patient monitoring. So a doctor can give this to you and run it out. This is just a reference design for us, but
and
that's what it's
light
designed
enough,
for.
it'll stay on the body for...
It's light enough. It has electrodes and snap pins that stay on the body. It can last for 7 to 14 days on body.
Wow. Like this, just put it on,
just like that.
on.
It has a electrode that you can see in the picture here. So the electrodes are stuck on the body, and then the patch sticks on the electrodes.
And the battery lasts for this long also?
Yes. Yeah.
And
yeah.
what can be done with this?
Interesting, certainly. So the interesting part is this highlights our new AFE-based accelerometer and IMU. So the parts with the AFE in the numbers here, the 6-axis and the 3-axis. This is a standard IMU or standard 3-axis accelerometer that has an analog line added to it. And that analog line can be purposed in different ways. So in this case, in our ECG system here, the blue line shows the ECG picked up by the analog signal and the analog line in that MEMS device. The orange line is what's called an SCG signal, so a seismocardiograph. It's touching your sternum here, and it's measuring vibrations on the chest during the ECG. This is not a heartbeat here. Every peak and valley of this is a heart valve opening and closing.
And this is accurate? Is this the way that ECG is the most optimal way of measuring it?
The top part is the way the ECG is standardly measured, and this is called a 3-lead ECG for measurement purposes. The bottom part, this is new, so this is enabled by the MEMS accelerometer.
Nobody else does that?
Nobody else does an SCG, no.
Does that mean it's more accurate information that can give
it's additional
better
information.
Data?
Yeah, it's additional information. So effectively, the ECG is the input going to your heart. It's the electrical signal saying to the heart to beat. The SCG is the output of the heart actually moving. And so you have a closed loop measurement here happening on one single sensor.
So potentially with algorithms, maybe AI or something, it could detect different things?
Yes, so this part has a machine learning core associated with it, and it's set up to flag issues. So it will stream constant data if you want it to, or it will sense the data and then determine when there's an issue. So it can determine if there's an issue on the ECG. So there's approximately 32 different funny ECG signals that are documented and that it can pull out. Or if you have a differential signal between the SCG and the ECG, it will flag that and pull that out and send the data to your doctor.
You were mentioning accelerometers?
Yes.
So is that how it's detected usually? Is just an accelerometer moving a little bit?
So normally how it's detected is an analog line. So ECG is 100% analog, which is the top portion here.
Which is electric signal.
Electrical signal, yeah. It's a potential across the heart that you're measuring.
That's the normal way.
That's the normal way.
And now it's also with the accelerometer.
Yes, with the mechanical movement of your heart added to that.
But there's so much in the healthcare industry, there's so much about measurement of heart, cardio, everything. Is this technology already implemented in other ways by people, or is this the first time it's being done?
So this is the first time it's being shown. It's been through papers and other types of development. So seismocardiographs or microphones or other accelerometers on the body to measure vibrations exist. There's a company in California called Echo Health that's a partner of ours that does development of a microphone that looks at different parts of your body. The challenge is
listening in there?
Listening at your body, yeah. But if you listen at your stomach, you have all sorts of noises, and you can't tell whether you have stomach cancer or you ate Taco Bell. So you have to develop a library of sounds and movements in order to catalog that. So it's very, very difficult. So
but
listening is harder.
This is not sound, the system, right?
This is not sound, but it's creating vibrations, which is what sound is. So it's taking sound or vibrations and turning them into electrical signal.
Is it very accurate and very, what do you call it, It has to be very accurate, or how does it work? Like in the small vibrations?
In the small vibrations, yeah, the challenge here with the small vibrations is that it can be disturbed by movement, by skin, by clothes on
just
top,
moving on it?
yeah, can disturb the signal. So to get a very clean signal, just pure out of the machine, you have to be laying on your back doing nothing with no shirt on. If you want an accurate signal while you're moving around and while you're dressed, then you have to add in filters through either this sensor or additional sensors to take out some of that noise that's generated.
And the machine learning or the AI can kind of like figure out what's needed data and what's just
Yes.
discarded data.
Exactly. Yeah.
And it works?
Yes.
And so this mannequin here,
Sure.
I see different things happening.
Yeah.
Is it just this you're talking about right now?
No, we have everything. We have a lot of different things. So on the neck up here, we have a continuous blood pressure monitor. And so this is a device that's in development with ST, where we're showing and highlighting a new technology.
Continuous
Blood pressure monitor. So today's blood pressure monitor is going to be a cuff, right? You put on your arm and you take
and you
the
check 3
measurement.
times a day or something, if you do.
If you have to. Most people check once a year at the doctor.
Yeah, once every 3 years.
Yeah.
Then now it could be continuous.
Continuous, non-invasive, non-puffy. So this mounts, so there's a pair of accelerometers that are a little bit dark here that you can see. So one here and one here. It mounts on the carotid artery in our development system. And as your heart beats, your carotid artery expands. And the first accelerometer has a displacement, and then the second accelerometer has a displacement. You know the distance between them, you know the time it took, so you can create a pulse wave velocity measurement. You calibrate that with a known device, and then you can create measurements that are continuous over time. So
And
this isn't an actual measurement, this is just my PowerPoint drawing here.
Is it accurate?
It is, we're not shooting for accuracy, we're shooting for precision. So I don't mind if this is 5 or 10 points different than my blood pressure cuff. What I care about is that the device measures precisely over days, weeks, months, so it doesn't trend differently. So I want a measurement for Nicholas, and I want that measurement to show me what happens when Nicholas goes to sleep, when he exercises, over the next 3 months, as he loses weight or gains weight, what changes with his body. And so I can track this and then maximize it and combine it with other measurements.
Is it possible to design something that's actually trendy and looks cool and like, kind of like a necklace or something,
Yes.
like that you have to wear? That's kind of cool, but
Yes.
how is it going to fit?
So this is on the carotid artery because this is the single strongest blood pressure signal
So it has
on the
to be
body.
right there?
On the body for development and testing
Maybe you
purposes.
could integrate it with some kind of a...
So our goal is not to leave it here, right? This is also a first generation board where we just put everything in there and said this will work for testing purposes. So we've tested this on probably 30 people and gotten data, and we're starting some trials with some larger demographic populations to see how this works.
But with
if we're successful, we can then start considering moving it, right? So your next artery that's strong is on the inside of the leg, and then you have other arteries, but we'd like to get to the radial artery on your arm here. We'd like it to integrate with a band.
Is it most accurate to be on the neck? Because
Yes.
it's the big
It's
artery.
the strongest, it's the best measurement
It's the
you
best
can possibly
one.
get.
So wouldn't it be cool if there was a jewelry partner, something that was like making something, you could wear it there?
Yeah.
And because some people might kind of need or want to have it a lot during the day. Does it make sense?
Yes, and that's possible. What we're finding when it comes to wearables is nobody wants 6 wearables on them on the body, right? They don't want an ECG and a blood pressure and a watch and a different heart rate monitor. You don't want to get geared up. And so we have to combine and collapse into devices like a watch or like earphones or other devices in order to...
Smart glass.
Smart glasses
has
could
a
be the
little
hub.
thing there
Yes, that goes to your
on
ears.
the side of it.
Yeah.
And it
That's
just
very
hangs on your
possible.
smart glasses.
Exactly. So we want to combine as much as possible and move them to places. I think the watch companies have done a very good job adding health measurements. And then you have things like CGM, continuous glucose monitor, that's added to your arm. Well, that's great for right now, but hopefully that will integrate and move to somewhere that's easier to use in the future.
Are you doing it?
CGMs?
Integrating.
We're looking at it. Yeah.
And what else are you showing here? This corner.
What are we
What is
showing
this
here?
part?
So this is another ECG system based on a sensor tile
So you
system.
touch with
So
each.
it's a two thumb. Yeah, this is not set up to be functional today. Over in the corner there, Royce has a functional device.
Right. Should we go in the corner, or do you want to talk more here? Yeah. Okay. So here we have.
Do you want to?
Yeah.
Okay.
So one more here.
Okay,
Sorry.
one more. So
Yeah.
we have this AccuVein device, and this is a partner that we worked with to develop and deliver their technology. This is a micromirror. So it's a approximately 2 millimeter square micromirror that raster scans. So it's designed to move in a way that scans across an area, and it projects an infrared light onto your skin, across the skin. It has an infrared detector that can see what's being absorbed. So blood absorbs infrared. So it's seeing what's being reflected, just normal skin, what's being absorbed, vein skin. It creates an image, and then it has a green laser that projects that image back onto your skin. And so you can get real-time imaging of your veins.
Nice. It looks really cool.
So this helps doctors and nurses when they're trying to look
move
for
that a bit more?
veins. Yeah, and it's real time. Right on the back of my hand, you can see the veins moving as they move across my bones.
Nice. This is Terminator. This is like future stuff. Okay, so this could be certain doctors have one of those tools.
Yes, these exist in hospitals, in clinics today, and you can ask a doctor or a nurse, say, can I use the AccuVein device? And a lot of them have it, and they'll pull it out. So instead of being tried 4 or 5 times, you can just ask for this first.
What's the ST part in there?
So the engine, so the micromirror plus the laser plus the control systems are all part of the ST system here.
Nice. That's cool stuff. And what do we see here?
I'm going to have to turn you over to Royce because I don't know this as well.
Ah, okay. Sorry. I'll just cut there.
Don't get fooled by fake HDMI products. Only source authentic HDMI products from licensed HDMI adopters and authorized manufacturers and
resellers to ensure compliance. Counterfeit or unlicensed products can cause poor performance.
Certified HDMI products undergo official testing for safety and spec compliance.
Avoid brand damage, warranty issues, and customer dissatisfaction from unlicensed products.
long-term cost savings come from reliable, genuine HDMI solutions.
Unlicensed products may lack support and pose safety risks.
Use certified HDMI cables with official HDMI certification labels.
Report suspected counterfeit products at hdmi.org/resource/infringe.
Thanks to our global partners for helping keep the HDMI brand real and ensuring consumers get the experience they deserve.